In section R.3, which begins on page 19 of your textbook, we're going to continue with multiplication of polynomials. Last week we had addition and subtraction of polynomials. This week we're going to have multiplication. There are three different ways that we're going to multiply. The first one we've actually already had, and that way is multiplying by a monomial. We're only going to use the distributive property, which we had the first week of class. So if we go back to the distributive property, that means that whatever we have out in front gets multiplied by each of the terms that are inside. If we look at our first example, we have 2xy, and then we have a parentheses, and we have three terms inside that parentheses. So remember again, a term is composed of possibly a number, like you see the 3, and a letter that are side by side, which means that they're multiplied, so those are called factors. So, and the term always includes the sign in front of it. So in that first set of parentheses, we actually have three terms. 3x to the second is the first one, negative 2x is the second term, and minus 1 is the third term. There's one term on the outside, which is 2xy. So when we use the distributive property, we multiply the term that's on the outside times each one of the terms inside. That means we're going to have three multiplications. On the right-hand side, I've written that out for you. So you can see that it's 2xy times 3x to the second plus 2xy times the negative 2x, and thirdly, 2xy times the negative 1. However many terms that you have inside the parentheses is the number of multiplications that you'll have. Then we go and we process each one of the multiplications separately. So 2 times 3 is 6. X, which is to the first, times x to the second gives us 3 of those x's, so it's x to the third. There are no more y's, so the first multiplication gives us 6x to the third power y. The second multiplication gives us 2 times negative 2, which is negative 4, x times x, which gives us x to the second. We add the 1 exponents and a y. And then lastly, we have minus 2xy. So we can write our answer either as we have it on line 2 or line 3. Both are perfectly fine. Remember that when you multiply variables that have the same base, that means they have the same letter, then you add those exponents. On your practice test, problems 1, 2, 3, and 4 are like this. So, for example, on problem number 4, on the learning team practice test, there's one term on the outside, the negative 4x to the fourth y. Inside, there are 4 separate terms, so you're going to have 4 multiplications on that one. The second way that we're going to talk about is the long multiplication way. And what I'd like you to do on this problem is get a piece of scrap paper out and work the problem on a piece of scrap paper. Do not use your calculator unless you're checking your answer. So I'd like you to pause the video for just a minute and multiply 231 times 123 for me. When you've got your answer again, then turn the video back on and restart. Hopefully you got 28,413 for your answer. If we look at this problem, what the problem is we have 3 things times 3 things. And when we have those multiplied, we ended up with 9 multiplications. The zeros that we have in there are for placeholders. We took on the 123, we took the 3, and we took the 3 times the 1, the 3 times the 3, and the 3 times the 2, and our first line, after we drew our line underneath there, we got 693. We moved over one spot by putting a 0, and then we took the middle digit, the 2, and we multiplied 2 times the 1, 2 times the 6, and 2 times the 4, and got 462 for our middle row there. And then finally, we wrote down 2 zeros, and we moved over and got the 1 from the 123, and multiplied 1 times 1, 1 times 3, and 1 times 2. After we did that, we drew our line and added. So we did 9 multiplications and then we added. So in general, this is exactly how we're going to multiply polynomials together. We're going to multiply each term of one polynomial by every term of the second polynomial, and then we are going to add terms that are alike. If we look at the top example, we have something that looks kind of complicated. It's 2x to the second plus 3x plus 1, and we have x to the second plus 2x plus 3. If we look at the coefficients in front of those, we have 231, 2, a 3, and a 1, and we have 1, 2, 3. Those coefficients of those terms are exactly like the ones that we had in the example above, where we did multiply 231 times 123. So as we're working this example, you might want to refer to the one just above this that had that you worked also, and that just had numbers in it. So we're going to use exactly the same process. We're going to take the 3 on the second row from the x to the second plus 2x plus 3. We're going to multiply the 3 by every term on the top row. When we do that, we have 3 times 1 is 3, and that's a positive. We have a positive 3 times a positive 3x. That gives us a positive 9x, and we write down a plus 9x. And then finally we get the 3 and we multiply it by the 2x to the second, and that gives us 6x to the second. So we take the 3 times the 1 and get the 3. We take the 3 times the 3x and get the 9x. We take the 3 times the 2x to the second and get 6x to the second. We write our 0 down and we move over and we get our middle term, which is the 2x. Then we take the 2x times every term on the top row. So 2x times 1 is a positive 2x. 2x times positive 3x gives us 6x to the second because we're adding those exponents together. And then we take 2x times 2x to the second, and that gives us 4x to the third power. Again, we add the exponents together, the 2 and 1, and get a 3. So we now we have our middle row. You'll notice that the digits on the coefficients on each one of these terms are the same as the digits in the other example, the 4, the 6, and the 2. We write down 2 zeros and we move over and we get our last term, which is this x to the second. We take x to the second times 1 and write down x to the second. It lines up exactly underneath those other x to the second terms. We take our x to the second and multiply it by 3x and get 3x to the third, and we write it under the term that matches up. And then lastly, we get x to the second times 2x to the second, which gives us 2x to the fourth. So everything is lined up just like it did with the digits when we were doing simply numbers. We now draw our line and add, and we get 2x to the fourth power. We add the 4 and 3 and get 7x to the third power. We add our 6, 6, and our 1. We could write our 1 down if we wanted to and get 13x to the second. 9 and 2 gives us 11x, and finally 3 and 2 zeros gives us just a 3. So that example, if you look at each one of those, the coefficient of each one of those terms is exactly the same number as in the example of the one that you worked. Let's try another example now, which is the one down here at the bottom. Again, we have 3 terms times 3 terms. When we do that, 3 things times 3 things gives us 9 multiplications. So we're going to take the negative 3. A negative 3 times a negative 1 gives us a positive 3. Negative times negative is positive. Then we take a negative 3 and we multiply it by negative 2x. That gives us a positive 6x. Then we take a negative 3 and multiply it by 3x to the second, and that gives us a negative 9x to the second. We can write our 0 down if we want to, or move over a space. We get our middle term, which is the x. We take x times negative 1, gives us negative 1x. We take x times negative 2x, gives us negative 2x to the second. We take x times 3x to the second, gives us 3x to the third power, again adding the 2 and the 1 to get the 3. We go to our last term then, which is the x squared. X squared times a negative 1 gives us negative 1x to the second. X squared times negative 2x gives us negative 2x to the third. And x to the second times 3x to the second gives us 3x to the fourth power. We add the exponents of 2 and 2 and get 4. We draw our line and add. We get 3x to the fourth. 3 minus 2 is 1x to the third power. Minus 9 minus 2 minus 1 gives us minus 12x to the second. 6 minus 1 gives us 5x, and we bring down the 3. So as we look at this example, then we've done our multiplications, we've drawn our line, and then we've added. On page 3, there's an example for you to try, and the answer is down below so that you may check your answer.